Hello everyone, it's Andrew. I'm going to be showing you how to work with a mixture exercise. You'll see something similar to this in your homework. It won't be the same, but it's similar. And I'm probably going to post another one a lot like it. So we have some things going on here, right? First of all, it's asking us to mix together soy meal and cornmeal to get a 320-pound mixture that is 10% protein. We know that the soy meal here is 16% protein. We also know that the cornmeal is 8% protein. Now, they want to know how many pounds of each should be mixed together. And in mixing them together, we will generate a 320-pound mixture that is 10% protein. So how do we start? That's a good question, right? Well, what we're going to end up doing is, we mix these things together. So first of all, we should talk about that. They're adding. We're going to be adding a certain mass or weight of soybean and a certain weight of cornmeal together, and that's going to give us the overall mixture. So let's write that down, okay? We're going to say soy plus corn equals the mix. But we're only really concerned with the protein, right? So what we really need to know is we need to know how much of the soy, the 16% soy, and the 8% cornmeal, call it corn, equals the 10% mix. And the question becomes, how do we solve that, right? Well, I think that problems like this are more easily solved when we create a table. So I'm going to start off by creating a table. Hopefully I'll save myself enough room to work. So here we're going to put the meal, the kind of meal. Now it's going to vary a little bit, right? The first one we've got soy. And on the second one we have corn. And for the third one we have the mix. Okay, the next thing that we're going to worry about is we need to worry about the weight of the whole amounts in pounds. Now the next thing we're going to need is we're going to need these percent values. The 16% for soy and the 8% for protein and the 10% for the mixture. We're going to need to turn those into factors from their percentages. So when you have a percent, the words per and cent kind of have their own individual meaning. And when something is per, like miles per gallon, okay, that means to divide. Like in miles per gallon, we're saying miles divided by gallons, and that tells us how much each individual gallon will allow us to travel. So here we're saying per cent, so we're saying how much each part of a cent gives us, okay? So this is divide, and cent is kind of like 100, like century, or cents in a dollar. So we need to take whatever our percentage is, and we need to divide that by 100. So I'm going to do that. I'm just going to write the symbol percent here, but we should know that that means we take the percentage number and we're going to go ahead and divide it by 100. And I'll do all the math over that for on the right-hand side. We'll do that shortly. Now, what is this going to give us? Well, it's going to give us the amount of protein, right? The weight of protein. That we need, I misspelled protein. Weight. Okay. So they gave us the amount for the mixture, right? It's up here. It's 320 pounds. So we're just going to say the mix is 320 pounds. Okay. Well, we don't know soy. And, well, we don't know corn. What we do know is we know soy plus corn equals mix. But like I said, we don't know soy or corn. So let's just start off by picking a variable for one of them. I'm going to pick soy, and I'm going to call that variable x. Okay? And then I'm going to I don't know what corn is. I don't know an equation for corn. I don't know a variable for corn. I can't just pick y, because these things have to be relatable. They have to use the same variable. So what I'm going to do is I'm going to say, well, I know that soy, just copy it here. I know that soy plus corn equals the mixture. So let's sub in the values that I picked for weight. So soy was x. We don't know corn still. But we know the mixture, it's 320. So if I want to know what corn is, looks like I need to subtract x from each side. Now I know the weight for corn. It's a little equation called 320 minus x. So this is 320 minus x. We now have weights for everything. And we know that it works out, not only because we use the soy plus corn equals mix setup down here below, but we also know it because we could quite literally take and add 320 minus x, and we could add x, so we're adding soy and corn together, and a negative x and a positive x cancel, and it equals 320, which is the amount of mixture we started with. All right. I did this percent divided by 100 over here on the right. So let's work on that now. I'm going to say, well, soy, right? Its percentage was 16%. I'm going to divide that by 100. What am I going to get? I'm going to get 0.16. That's our factor that we're going to use to multiply against the weight to find out what the fraction, the smaller portion of the weight of protein is. So that's 0.16. We're going to do the same thing for corn. Corn is going to be 8% divided by 100. So I don't know if you noticed, but we moved a decimal place over 2 spots because we had 2 zeros, like that. So we're going to do the same thing for the 8. We're going to move over 1 and then 2. And because we have an empty space here, we're going to call that 0. And there's a decimal there. So our answer here is 0.08. And we're going to plug that into our chart. Now for the last bit, we're working with the mix. Okay? And the mixture is 10%. We're going to divide that by 100. Same technique, and we get 0.10. We have one final step to solve out all the open spots here in our table. We need the weight of the protein. Well, all we have to do is multiply the weight in pounds by the percentage, and it will equal the weight of the protein. So we're multiplying from left to right along our table. So soy is going to be 0.16x. And we'll put that in the table. And do the same thing for corn. And corn was 0.08 times 320 minus x. Now, I am not going to do this one in my head. I'm going to jump over to my calculator, and I'm going to say 0.08 times 320 equals 25.6. So this is going to be 25.6 minus 0.08x. Now, some of you may be questioning how I got that. So let's talk about that real fast. I used a property called distribution. I took this number on the outside and I multiplied it to every part on the inside, one by one. This gave me the 25.6 when I multiplied 320 by 0.08. And 0.08 times a negative x is a negative 0.08. It's a negative times a positive, which means we're going to get a negative result. And there's an invisible 1 in front of the x that we're multiplying by. So we're going to put that into our equation over here, or into our table, I mean. So this is 25.6 minus 0.08x. Well, I did not write that in very well. It's okay though, right? We can see it, and in any case, it's right there, right? Now for the mixture. Well, the mix. So 320 times 0.10. What does that equal? Well, let's just check it on a calculator. $32. All right. For those of you who are following along and writing, great job. I'm about to delete everything except for the table. Little formula relations up above. So now you're probably wondering, how did this help us? I don't blame you. But remember I started off and I said we needed to figure out the protein amounts? Well, here's the protein amounts, right? So this 16% soy is this. And this 8% corn is this. And this 10% mixture is this. So we're just going to substitute these things in. We're going to say 0.16x plus 25.6 minus 0.08x. And that's going to equal 32. Okay. So here is where we start combining like terms. All right. So I'm going to start off with my first variables. These are both, they contain a coefficient with an x to the first power. Both of them do. Okay, so I'm going to look at these two. I'm going to combine them together. All right, so 0.16 and negative 0.08, those are going to add to become 0.08 positive x. Okay, I still have the plus 25.6 equals 32. These things are gone though now. Like they became this new thing, 0.08. And just to prove it, there's the 0.08. So now, to get the x by itself and isolate it, we need to move the 25.6 to the other side. So here, they cancel. I'm just going to bring the 0.08x down. And then I'm going to subtract 25.6 from 32. Well, I would do this in my head. I would say 32 minus 25, that's going to give me 7, but then I'm still subtracting 0.6, so that would give me 6.4. Let's check it. .4. Now what we need to do is we need to divide. If I divide by the coefficient of the variable, then I'm going to get 1. So this will just become an x. And that x will equal 6.4 divided by 0.08. So, I don't know, I think this might be 80, but I'm actually not going to claim it. I'm going to say 6.4 divided by 0.08 equals 80. 80. Now what was x? X was soy. So we're going to say that's 80 pounds. I might want to label this solutions. Let's do the next one. Okay. So if x was 80, I already have an equation, a sort of an expression, right? To know what corn is. So let's plug in the 80. Well, I believe this is 240. But I'm going to check it just to make sure. $240. We're good to go. And when I add them together, I definitely get 320 pounds. So, let's go back up to the top here. Highlight this again. Pick a nice green color here. How many pounds of soybean meal? Well, soy was 80, right? How many pounds of cornmeal? How many pounds of cornmeal? Well, that's 240, right? And we have just solved a mixture problem. I hope this helps. Feel free to leave comments. I would appreciate that. And I'll be posting this in the discussion board for our class. probably going to work on another one here shortly. So